Okay, I've got a couple of questions from Math 120. This one is 6.1, number 25 online, and basically you have a graph or a bar chart or a histogram that shows the probability to the right of the number of births by a mother who had a live birth in 2012. Okay, so this is the probability that a mother will have one by natural childbirth is 0.239, that she'll have two, 0.249, that there'll be 3 children born of natural childbirth, 0.169, 4 children, and so on. So, and these women are from 44 to 49. Okay, so that's what we're looking at. Now you can also put this in a graph form like you're used to doing with the problems that we're doing. So I'll go ahead and do that for you. Let me just do it with my pen if I could write. I don't know if I can do it or not, but in the beginning of this chapter, here's your x, and this is your p of x. Well, this is the same thing. You just write 1, 2, 3, 4, 5, 6, 7, and 8. And then you write down the probabilities. 0.239, 0.249, 0.169, 0.113, 0.105, 0.036, 0.041, and 0.048. Now, the first question says, and all this stuff is just redundant, but has her 4th live childbirth. Well, 4th would be 0.113. So you take your handy dandy cursor and you put it over here and punch in 0.113. Next, her 4th, or, remember or, what does or mean? Or means what? Or means additive law. So you're going to add them together. 4th or 5th. So that would be 0.13141. 141, I believe. 5, 4th or 5. 141. No, I did 5 or 6. 4 or 5 be 0.218. If I did that correctly. And then it says 6 or more. Well, then you'd add these up. 6 or more. So that'd be 0.77 and 0.77 be 0.125, right? Yeah, 0.125. This question says blah blah blah, how many would you expect? That means they want the average, so you got to multiply all these together and add them up. So I'm going to pull up the handy dandy spreadsheet because that's the easiest way to do it on this screen. Not that you have to do it by the Excel spreadsheet. You can do it in your calculator if you want to. Remember, I do not show the Excel spreadsheet because you have to learn it. I show the Excel spreadsheet because it's easier for me to present than to write all this out. So I know some students feel like they have to use Excel. You do not have to use Excel. I'm just showing you what to do on paper using the Excel spreadsheet. So I'm going to put this in here right quick if it ever comes up. And I'm going to pull this over here a little bit where you can see it better. 1, 2, 3, 4, 5, 6, 7, 8, and 0.239, and 0.249, and 0.169, 0.113, 0.105, 0.036, 0.041, and 0.048. Now remember, the mean of a probability distribution is equal to the summation of P of X times P of X. Oops, sorry about that. X times P of X, meaning that you take each one of these, multiply them, and that's what I'm fixing to do right now, and put it up here. I'm going to put X times P of X. I'm going to take this number and multiply by this number, and I'm going to copy that down, and I just did X times P of X. And what does this big E mean? That sigma means you add all those up, and when you add all those up, that gives you the mean. And there's your mean, 3.108. And let's see what it says do. It says round to 1 decimal place, and we got 3.1. So it should be 3.1. And that's that. And that's how you do that question. And of course, you can punch those in your graphing calculator, and you could get that by hitting one variable statistic, and it would give you the 3.1. Okay, so that's that question. Let's look and see what other questions we have. This is 7.235. 7.2, we talk about area under a curve, and whenever you're doing these, the first thing you're going to look at is the mean and the standard deviation. That's always. So draw you a picture, and on these you're always going to draw a picture. So here is my picture, and that's your mean, and 2 standard deviations this way and 2 standard deviations that way. 50 goes in the middle because that's your mean. This is 57, and this is 64, I guess. 50 minus 7 is 43, and 43 minus 7 is 35, I think. 43 minus 7, no, 36. All right, now they say, now that's all that. You don't need that. That's what's that's for. Find the 96th percentile. So that means 96. We know this is 2.5 by the empirical rule. We know this is 13.1. We know this is 34. We know this is 34. And we know this is 13.1. Now, if you read from left to right, which most people do, 98% is going to fall right in here. But it's going to be a little bit further because this is 2.5. 100 minus 2 is 98. But this is 2.5. So I would say I'll take my red marker. I hope it's red. And I'm going to draw it. No. I'm dealing with 2 mice at one time. My pen mouse and my regular mouse. So 98% is going to fall right in here. And the reason it's going to fall right in there is because this is 97 point. This black line right here represents 97.5 because this is 2.5. So if you move it over a little bit, you'll be right at 98. So 98 is right in here somewhere. And if you don't know your empirical rule, you don't know what I'm talking about. So go back to page 137 or 138, I think it is, and read the empirical rule. The empirical rule will give you these percentages. Right there. Okay? So we've got a 98 percentile, which means that this whole area is 0.9800. That's 98%. So everything this way is 98%. That's what it's asking. And this over here is 2%. We'll take our handy dandy blue marker and we'll color this little area right here blue because that's 2%. Okay? So now you go to your handy dandy table, and your handy dandy table is right here. And I'll hit it again. There we go. And you look up 98%. And I'm looking, I'm trying to get it 98%. Excuse me. Gonna have to go down. There we go. We got some big numbers down here. 0.9800, 0.98, there's 0.9838, 9830, 9821. Okay, what's closer to $98? Let's look and see. 9803 or 9798? Which one's closer? Well, this is 3 cents from 98 and this is 2 cents from 98. So 2 point, let's see, that'd be 0, 1, 2, 3, 4, 5. 2.5, I believe. Look. Yep. 2.05 is your X. This line right here, this red line, that is a z-score right here of 2. I'm sorry. I'm not getting much help with my mouse pen. There. This line right here, I'll color it blue now, which represents 98%, has a z-score of 2.5. Now, I think if you look, I think they want a score that represents the 98th percentile. And click, let's see, 98, yeah, they want a score. But 2.5 doesn't give us a score. So we have to use what I use in class, and that is X. Really? Here we go. X is equal to Oz plus mu. Oz plus mu. So that means X, which is your temperature or your score or whatever they're looking for, is going to be your standard deviation, which is 7, times the z-score, which is 2.5, plus your 50, which is your average. And 7 times 2 is 14, and then half of 7 is what, 3.5, so that'd be 17.5 plus this is 67.5 or something like that. I don't know what it comes out to be. Let's see, 7 times 2 is 14, and half of 3.5, yeah, I think that'd be right. 17.5 be 67.5. So we take your handy dandy cursor and we'll type in 67.5 and see what we get. Okay, let's see what they got, because evidently we didn't do it. Excuse me, I got a sneezing attack. Okay, we did something wrong. Oh, I know what it is. I said 98. That's 96. That's what it is. My bad. So 96 percentile. 96 percentile. Go right here. Go back down. 96 percentile is down here. There's 90, 96. I'm looking at 90. Here we go. 95, 99, and 96. So that one's 1.7, 0, 1, 2, 3, 4, 5. 1.75. 1.75 needs to go here. So my bad. I read the question wrong. This is 1.75. And that's 1.75. And 96% would be on this side, not 98. 98 would be on this side, 96 would be on this side. My bad. 1.75. And that's going to be 7 times 1. And then that's going to be, I don't have my calculator, but that would be right. Sorry about that. And for those of you that don't know what I did, I thought the question was asking for 98% right here, and it was 96%. So that's why I had 2.05. So my bad. And I'll be showing some more of these as I'm going through class. I'll be showing some more of these. So you'll be getting it as I show more and more videos on the area under a curve. Okay? And I hope this helps.